I'd now like to move on to our last speaker for today's talk. We're very privileged to have Dr. Ian Oppermann. He's the New South Wales Government Chief Data Scientist. He's within the Department of Customer Service. He's also an industry professor at the University of Technology, Sydney, and he was the CEO of DAC, which is the New South Wales Data Analytics Centre. Ian is also involved in DARE, and it's with great pleasure that I welcome Ian to talk.
Thanks very much, Sally. I really have enjoyed these presentations. I have to say that this is one of the best events I've been to for quite some time. The approach I'm going to take, what I would like to talk about, is a little bit different. And having seen Roman's presentation, I have no compunctions whatsoever about throwing a couple of junior equations at you. But the uncertainty that I'm talking about really is the uncertainty about what are we giving away? What is the amount of personal information that we release when we share data or use data or even release data to the outside world? And it basically comes down to this fundamental premise that if you keep, well, there's a widely held belief, if you keep linking data sets together, people-centric data, at some point you will reach the point that the data is personally identifiable, even if it is de-identified in the sense that we typically mean it. And information about eye colour, hair colour, shoe size is personal information, but it's not personally identifiable unless you know a lot more about individuals in the data set. So the concept that I've been working with over the last 4 years is trying to identify a personal information factor that would allow us to measure how much information is released for someone you know is in a data set, and also something about the risk of re-identification. And of course, context matters. And the context that we typically talk about are rich and varied, where you are, when you are, who you're with. To simplify the way of thinking about this data sharing challenge, what we've done is taken simply the context of closed analytical environment where no more data gets in or gets out, and it's just the algorithm looking at the data. When data or insights are released to an individual who will be in a controlled environment, such as someone who's got a restriction on the use of the insight, or someone who is not part of the data set, or someone who has a moratorium on what they can do with the insights. And the third context is when we release data to the outside world, where we effectively have no restrictions on who accesses the data, how much effort they put into trying to recombine or re-identify, or which other data sets they might try to re-identify. That simplifies the infinitely complex world into just 3 different environments, but it also makes the thinking about this problem a whole lot easier. Now, very often, data sharing is inhibited by concerns about privacy, or at least they're articulated to be about privacy. You can't have this data set, I can't give you this data set, I'm not allowed to give you this data set because of the Privacy Act, the proper reason. But really, most of the time, it's not about privacy. Most of the time, it's about what happens, what the data is about, so sensitive subjects of the data. And these are described, if you go to the Australian Bureau of Statistics website, you can see what is meant by sensitive data subjects. There's also a concern about data quality, aspects of the confidence in the outputs that are produced using different aspects of data quality, consequences of use of those insights, concerns about whether human judgment needs to be applied before that insight can actually be taken care of. So we go back to a judgment situation as opposed to a data-driven decision. Possible harms resulting from the use of the outputs, those insights, results from analysis leading to negative surprises, with read embarrassment. Or expert knowledge or context required to appropriately interpret the results, or concerns about accidental release of the data and loss of exclusive control. And sometimes, even if the data has never been looked at, you can guarantee, those who have looked at data sets, you can guarantee you'll find something interesting in a data set that's never been explored before. The 2 I wanted to very briefly touch on were concerned about data quality and confidence in the outputs and the impact of data quality on an algorithm. Now, for my sins, I've been working in the international standards community for the last 4 or 5 years, trying to tackle this issue of data sharing and use, and thinking about data sharing and use right through the entire chain of data lifecycle. So from create, whether it's created by a human or a sensor, transmitted again to an electronic recipient or to a human being, storage, analysis, and reuse of those analysis insights, archiving, and ultimately deleting. And those cryptic numbers on the side are the international standards communities that I've been particularly working with. So SC27, who make the famous cybersecurity standards, SC32, who have developed SQL, which I'm sure we're all familiar with, SC38, who build cloud computing standards, SC40, who do information management, and SC42, just who do artificial intelligence, just to name a few. And the question we've been asking is, could we identify all the bits of information, all the metadata that we need from that total data lifecycle so we could calculate the level of quality which is appropriate for an algorithm, which is generating an insight, which then gets used for a certain use case. So what we've been doing is trying to map out what we mean by data quality. And it's a remarkably elusive question because there are so many different instances of descriptions of data quality for particular use cases, for particular algorithms, for particular data sets. It turns out there is no generic description of all the information or the metadata you need so that you could calculate leading up to the point of use of data, whether it's appropriate quality for the particular algorithm that you're going to use. So we tried to start to map that out. And this is working with the folks who developed SC32, the SQL standards, because they have an interest in it. And the issue, of course, is the data quality appropriate for this algorithm? Ultimately, it speaks to the question of, is the algorithm sensitive to the data quality? And is it sensitive to all those different sorts of bias or incompleteness or population sampling rate, or all those aspects about whether or not that data is capturing a realistic view of the world, which is realistic enough for the use of your algorithm. And then what does the algorithm itself do in terms of the different levels of bias, the level of specificity, the sort of errors that were being discussed before, false positives and false negatives? And can we actually know that? And it looks like it's an infinitely complex problem. That's the bad news. The good news is that it looks like some finite complexity understanding and capturing of data will be sufficient for many of the use cases that we care most about. So this work has really only just begun. But here's where it gets interesting. If we're able to really understand how personal the data is, how much personal information is in the data sets that we've got, and what those inherent sensitivities are. And sensitivities may be a bad word, but again, think about concerns about data quality, concerns about appropriateness for the algorithm, concerns about the use of the insights, concerns about how much human knowledge or judgment needs to be re-injected, concerns about the level of context that's required. We can start to look at how we would build data sharing and governance frameworks which allow data to be shared, allow data to be accessed, and allow data or insights to be surfaced rather than being battered away for reasons of poor quality, inappropriate use of an algorithm, or all those reasons that ultimately people put up when a result comes out that they intuitively don't trust or really don't want to be surfaced. So it is all a means to an end. And this is where we've been slowly but surely stepping through, thinking about data sets based on how personal they are and how sensitive they are. There are two major dimensions of personal, which we'll get into a moment. And we've identified 12 main components of sensitivity, which relate to things like data quality. But if you know where you sit in this matrix, of this very simplistic matrix, then you can build governance frameworks which are relevant for highly personal, highly sensitive data sets, such as the work we've been doing around domestic and family violence and reform of the out-of-home care system, kids identified at risk of significant harm. But many, many people hang on to their data as if it's always in that top right-hand corner. In practice, of course, working with the folks at Transport for New South Wales, they have data which is not very sensitive. I mean, a train journey is not terribly sensitive, but there is still a strong aspect about privacy which needs to be ensured that we're following. So we can build data governance frameworks in that bottom right-hand corner, or in the case of, for example, Infrastructure New South Wales, they have sensitive information about planning decisions, which is not very personal. It may make use of aggregated traffic flows, for example, but it's not terribly sensitive. So the governance framework is steered towards the sensitivity aspect. And then there's open data, where we want to make sure as we release more and more data that it's appropriately desensitized and it's also appropriate levels of personal information. Now, we've been stepping very carefully through this process for quite some time. And this is my version of an equation. So hats off to you, Roman. This is my beginner's equation for 10. We've been looking at building an personal information factor tool based on an entropy-based understanding of an attacker model. And it's really very simple. If we assume that an attacker or looking at the data set is trying to re-identify or try to learn something about an individual, if they know if the individual is a row and every feature is a column, if they know that an individual is in a data set and they know everything about that individual, feature 1, feature 2, and what they learn is feature 3, then the change in probability of that feature prior to and post being able to look at that feature is the information gain. And the worst case scenario is that the attacker knows exactly which row an individual is and uses it and learns every single value of every feature. And that change in probability is the total information gain. We call that the row information gain. And we say that the highest row information gain for the smallest cohort identified of equally identifiable equal rows is the personal information factor. In terms of the sophistication of a personal information factor, my analogy is that we're just building a Model T Ford, and this personal information factor is our speedometer, and our data sharing frameworks are our gearbox for driving this Model T Ford. And where we sit at the moment, this was being slowly but surely built up, slowly but surely being tested with different agencies. Then COVID hit. And so all of the things that we've been slowly but surely testing in those sharing frameworks, suddenly we were in a situation where there is a very compelling reason to release information about confirmed cases in New South Wales and testing. There is an international already a precedent of New Zealand, of Singapore, of many other countries that we regularly work with, putting out really quite sophisticated, really quite sensitive amounts of information, large amounts of sensitive information. So the question in New South Wales was, could we identify from the raw data sets the most information-bearing features, so the columns? Could we identify the most information-bearing individuals? And could we then build out a tool which allows us to look at the original raw data and look at different ways of protecting? And what we effectively did was exactly that. We looked at which features actually not only carry the most information, but also which features have the most mutual information between them. And a feature that has two features that have high mutual information means that you're effectively giving away less information when you give away both features than if you give away two features which have very low mutual information. We also found a way of looking at the data quality by looking at mutual information. So the diagonal is the mutual information of any one column with itself, and it should be 100%. And if it's not, it means we've got some data quality issues. So we found a really quick way to tell whether or not we had a data quality issue. And so using this approach of identifying the hottest columns, those with the most information, and identifying those features with the highest mutual information, we started to break down the raw data into different tables. So our raw data of table 1, which is the red column here, this is a cumulative distribution function of all those row information gains. So the worst case scenario is you gain all the information about an individual that you know is in the data set. And so we plotted all of those every single day and said, this one right up here, this is the one we care about most because this defines our personal information factor, assuming there's only one of them that's identical. If there are two that are identical, then it's the next one down that identifies that personal information factor. And so we broke the data up into different tables to push down this personal information factor. So from table 1, the raw data, we broke it down into location and date of notification, so table 1. Table 2, which was location, so notification date and age. And table 3 was notification date and likely source of infection. And we reached a level of comfort that every single day we were pushing this personal information factor down sufficiently that we actually, after a while, recombined table 1 and table 3 to produce table 4. We put information back together because we were comfortable enough that this ratio of change from the highest level in the raw data to table 4 was actually good enough in terms of the extra level of protection. So it's not an absolute number that we've come up with, it's actually a relative protection compared to data that we would otherwise have released. Every single day, the personal information factor tool gets run over the COVID data. It happened today, it happened yesterday, and thankfully it doesn't happen on the weekend anymore. And we push this data out based on the level of comfort that we've got. We've also, and that produces the COVID map, which allows us to do geospatial mapping of the postcodes of confirmed and of testing cases. And we were also looking at what other parameters we could put out. We put out the recovered at one point, but then realized that as the numbers started to get quite small, there was enough ambiguity in those results that we're actually potentially putting out not the most useful information. So over the last, now it has been 3 months, just slightly over 3 months, every single day, The personal information factor tool has been run over the data, and we've looked at not just the day's data that goes out, but every data set that we've ever put out related to COVID information, and some of the table too we stopped releasing a little while ago. So where we currently stand is that our slow but steady process of building data sharing frameworks and building ways of understanding where we sit in terms of sensitivity and personal information, we've been trying really hard to quantify a measure of that personal information. We keep working on existing open data sets with other agencies in New South Wales to try and find out what we were already comfortable with and whether or not it's okay to keep pushing this data out for different levels of sensitivity. COVID data certainly is very sensitive, but that need for transparency and the need to get data out while still protecting personal information has been our primary objective. So thank you very much for listening today.